calculation of rate of reaction. So let's see, for example, if A changes to B, A is reactant and B is product, that we know. Then what is the stoichiometric ratio of this reaction? What is the stoichiometric ratio of this reaction? 1:1. What do we mean by stoichiometric ratio? The number which is present before the reactant or product after balancing the reaction. So here stoichiometry ratio is 1:1. This is the first point. 8. So let's take with respect to time. No, the rate of reaction is going to change with respect to time. So let's take T, if T equal to 0 means at the starting of the reaction. So then let's take the concentration of A. Concentration of A is A0. Obviously B is 0 only because the starting of the reaction, no product is going to form. So the concentration of B is 0. At T is equal to 0, concentration of A, let's consider this one as A0, and for B concentration is 0 because at the starting no product will be present. If after some time, let's consider T equal to T. This may be after 2 seconds, 5 seconds, whatever it may be. Let's take this one. After some time T equal to T only, then the concentration of A is equal to AT. Then what happens here? What about the concentration of B here? How much the concentration of A lost is equal to the amount gained by B. We are converting one compound, we are converting one reactant into product. After some time, the quantity of the reactant reduced. So obviously the same quantity of the product also formed. So after some time, let's consider this one as BT. Concentration of the reaction is BT. Some concentration will be present, obviously, when compared to T equal to 0. After some time, concentration of B will be present, but not 0. So that will be BT. Then, by looking at these two things, what we understood? A0 is greater than A0. Obviously, starting A0 will be more. After some time, the concentration of reactant is reduced to AT. So obviously, A0 is greater than AT. This is the initial concentration. A0 is the initial concentration and AT is the concentration after some time. Then, if this is equal to X, if we consider, this is equal to X, so how much the concentration of A, that is equal to AT equal to A0 minus X. If suppose the concentration of A at the beginning is X, then after some times what happens? A0 minus X will be present. And the same X concentration will be of B. Because after some time, the quantity of A reduced is equal to concentration of B produced. So now let's see what is the rate? How can we calculate the rate of the reaction? Let's see. So we can say that rate of disappearance of A is equal to rate of appearance of B, we can say simply. how much quantity is disappeared from A is equal to the quantity appeared in case of B. So first let's see rate of disappearance of A. How can we calculate this one? Rate of disappearance of A. Change in concentration of A with respect to time. That is our definition only. Rate of disappearance of A is equal to change in concentration of A by time. So let's see, let's substitute this one. What is the change in concentration of A? That is change delta A by change in time delta T. What is delta A here? Final concentration, change in concentration, AT minus A naught. Final concentration minus initial concentration by what is change in time after T seconds, after T, and initial time is 0, T minus 0. And substitute the value of AT, A naught minus X minus A0 by T minus 0. So plus A naught minus A naught, that is equal to minus X by T. So delta A by delta T equal to minus X by T. That is equal to rate. Now, is it correct? No, this is not correct. Why? Because rate will not be in negative quantity. Will not be in negative quantity. Rate should always be in positive, not negative. So, what is the solution for this? The solution for this is we need to put minus. So that is equal to minus into minus plus. Two reasons to add minus. One is, basic thing is rate of disappearing, means it is reducing. So that reducing quantity should be represented by minus, as it is reducing, disappearing, vanishing. So we need to represent this rate of disappearance with the negative side, so that we'll get positive answer, as rate should be always in positive but not in negative. Then rate of disappearance of A is obviously equal to rate of appearance of B.